Okay, last time we saw processing n jobs through two machines, and we used the principle of Johnson rule, if you remember, and we solved the problem. First of all, we found the sequence, the right sequence, and then we also calculated the elapsed time and the idle time for both the machines. Okay, now going forward, let us take an example, or let us see how to solve n jobs on three machines. Okay, now in this case of problem, you will find that there are totally three machines given to you. For example, let us say A, B, and C are involved here. Now, each job is to be processed in the order of A, B, C. Okay, that is important. Or if they have mentioned any order, you have to follow that order while doing the calculation. Okay. Secondly, no passing of jobs is permitted. That is, the same order of job is maintained on each machine. Okay, you cannot pass the process in, or you cannot pass a particular job and uh, move on to some other machine. That is not possible. The expected processing time for all the n jobs on three machines are given like this. Last time we saw about two machines, A and B. Now you'll have one more machine called C, which will be included with n jobs. Okay, and your A1, A2, B1, B2, and so on, and C1 up to Cn, all these are your processing time. Okay, of the jobs 1, 2, 3 up to n. Okay, and as before, the objective here is also to find the optimum sequence of the n jobs, and to minimize, the main objective here would be to minimize the total elapsed time. Now, what is the method of solving such problem? First of all, we have to identify the smallest processing time on machine A and C. Now, because if you look at the steps which we had done in Johnson rule. Okay, before we actually apply the Johnson rule, we are supposed to complete this step number 1. This step is going to decide whether I can apply the Johnson rule on the given problem or not. Okay, so identify the smallest processing time on machine A and C, and also find the largest processing time on machine B. Okay, now check out if the smallest processing time on machine A is greater than equal to the largest processing time on machine B. Fine. The smallest processing time on machine A should be greater than or equal to largest processing time on machine B, and or the smallest processing time on machine C should be greater than or equal to the largest processing time on machine B. So either one of the condition or both the condition can be satisfied. If it is satisfied, only then you can go ahead and solve this problem using the Johnson's rule. Clear? If it is not, then you cannot apply the Johnson rule and the method which I'll be discussing further. So this step is the most important step in case of n jobs through 3 machines. Now, if none of the conditions are satisfied, the method fails. Okay. Otherwise, you have to go to step number 4. And what is the step number 4? Now, we have to convert this problem of 3 machines into a 2-machine problem. Okay. Now, replace the 3-machine problem by an equivalent problem involving n jobs and 2 machines. So we have to include 2 fictitious machines such that there's some calculation. Let us say I include machine, say G and H. Okay. So if I have a machine, G and H, the processing times of G, I and HI will be calculated like this. So GI will be equal to the processing time of AI plus BI. Okay. And for HI, it will be BI plus CI. Okay. The common processing time between both of them is the middle row or the second machine. Clear? Now, once we get this fictitious machines, G and H, and their processing times, okay, then we can go ahead and use the Johnson's rule to find the optimum sequence for processing the n jobs on the 2 machines, G and H. Okay, and of course, the order should be G first, and then followed by H. Now the sequence, the method you already know. The resulting optimum sequence also gives the optimal sequence for the original problem. So whatever optimum sequence I'll be getting for G and H will be the optimum solution for all the three machines A, B, C. Clear? Now the Johnson rule, you already know it. So let us take a problem and solve it. Let us take one exercise here. Now we have 7 jobs, each of which must go through the 3 machines A, B, and C, and in the order A, B, C. The corresponding processing time on the machines in hours are given as below. Now this is my processing time for 7 different jobs on the 3 machines A, B, and C. Okay. Now this has to be AI, BI, and CI. Okay, so this is A1, A2, A3, and so on. Okay, what are we supposed to find out? Determine the optimal sequence of the jobs that will minimize the total elapsed time, and also find the idle time of machine A, B, and C. Okay, now let us see how you do it. First of all, find out the smallest processing time on machine A. So let me give you the problem first. What is the smallest processing time on machine A? 3, right? Which is of A1. And the smallest processing time on machine C. There's a tie here. You can see C5 and C3 and C5 have the smallest value, that is 5 hours. Okay. Check the largest processing time on machine B. So what is the largest processing time? 5. Okay. And as you can see, your condition, that is C3 and C5, is equal to, or you can say greater than equal to 5. Here it is equal. Okay. We can say that it follows the, you can say, the rule, the check rule, which we have decided or described before. So if this condition is okay with us, that is the smallest processing time on machine C is either greater than or equal to the largest processing time on machine B. That condition is satisfied. So hence we can apply the extended Johnson rule method. Okay. So what is the Johnson rule method? We have to replace the 3 machines with fictitious 2 machines. So I'm going to introduce 2 machines G and H, and then perform the calculation and find out the processing time for G and H. Let us see the solution.
Combination channel blue.
So we have already identified the smallest processing time and the smallest processing time on machine C as well. Okay. And the largest value condition, it satisfies this condition for C and B. So the smallest processing time on C is greater than or equal to the largest processing time on B, and hence we can apply the extended Johnson rule. Now let us replace this whole thing and get the new table. So my new table will look like this. Okay. Now we have the machines G and H. The formula for finding out the processing time for G would be AI plus BI. And for HI, it will be BI plus CI. Okay. And this is what we have got. Now this can be used further. I'll create another table. And let us put it like this. So this is my new table. And I have added 2 more rows. One is to indicate the order of assignment, and the other one is to indicate the sequence. Okay. Now compare the processing time of all the processing time available. The one which is least, which is the least one. So from this table, you will find 6 is the least, and it belongs to the second machine. So this will go at the end of the sequence. Okay. And I'll process this as the first sequence. So I'll process this one first, So order of assignment will be first for job number 5. And because it is on the second machine, I'll be assigning it at the end. So you put the job number there. Clear? What is the next value? Once you do this, ignore this machine. So I'm not going to consider this job anymore, not the machine, job. Check for the smallest value. The next smallest value is 7. Okay, and there's a tie between these two values, and both are two different jobs on two different machines. Okay, so I can take any one of them first. So I'll process this one first and assign it at the beginning. Okay, so this will be 2, and because it's on the first machine, this will be at the beginning of my sequence. Okay, whichever slot is available. So I'll put 1 at the beginning, whereas this can be considered as the third order of assignment, and this will, because it is on the second machine, this will go to the end wherever the slot is available. So this slot is available at the end, so I'll put 3 here. Okay, what are the remaining jobs? Job number 2, 4, 6 and 7 are remaining. The least value here is 9. Okay, so 9 is the least value, and it is a part of the first machine, 4th job. Okay, there is no tie, I hope, no tie. So this will be 4, and it will go at the beginning of the slot which is available. So 4 will come here. Okay. Now the remaining 3 jobs, job number 2, 6 and 7, have the least value 10. Okay, so there is a tie again. So the sequence, you can decide the sequence again, if up to you. But remember, this is the smallest value, so this will go here. 7 will come here. So I'll assign 7 here. There's a tie between these two values, and it is for the same machine. Okay, so there'll be 2 alternative, you can say, solutions to this given problem. So either you can put 6 here at the end. 6 can come here, or it can come here. Okay, and either you can put 2 here or 2 here. That means there is an alternate solution. Please remember here. Okay, so I'm taking the second job as the 6th order of assignment and assigning it first, and then I'll assign the 6th job. So this is my sequence which I'm getting, and which is the optimal sequence for the fictitious machines G and H. And as I told you, the optimum solution which I get for G and H will be the same solution for my original machines A, B, and C. Okay, so my sequence for A, B, C can be again written, and we can find out the total elapsed time and the idle time like this. So again, create a table with the original values. Now I have put the values directly here. I have not done any animation to show you here. Try to understand what we have done here. I'll explain you the first 2, you can say, jobs. And if you have any doubts, you can ask me. Now, the in time for machine A is 0. Always start with 0. Okay, and this is my optimum sequence. This sequence which we have just found out. Okay, now check the processing time for machine A on or job 1 on machine A, which is 3 hours. So 0 plus 3 gives you 3. Okay. Once this job is out from machine A, it will come in for machine B. Okay. Till then, machine B is idle. Please remember. Till then, machine B is idle, and that is why we get idle time for machine B here as 3. The processing time of job 1 on machine B is 4 hours. So 3 plus 4 gives you 7. Okay. And the in time for machine C for job number 1 will be 7. Until machine C got this job, it was sitting idle, and that is the reason the out of machine B, that is 7, is the idle time for machine C, and that's why we have put 7 here. Clear? Then comes 7 plus 6, because 6 is the processing time of job number 1 on machine C, which we get 13. I hope the first job, how we got the values, is clear. Now coming to the second job, job number 4. Now, as soon as this machine A is free, that means after 3 hours it is free. So immediately it is going to take the next job. And the next job is job number 4. So we start the time in will be 3 years. So compare this out of machine A, that'll be the in for the next job. Okay. 3 plus 4 will give me 7. Now this time in can start at 7, provided it is free. Now the previous job is also getting over by 7, so there's no problem here. So I will start the in time for machine B for job number 4 is 7. And the idle time is 7 minus 7, that is 0. See, 7 minus 7 is 0. Plus the processing time will give me the timeout for machine B of job number 4, which is coming as 12. Now pay attention to this one. Now the job number 4 can start immediately on machine number C after it is completed on machine number B. But machine number C is still processing the first job because the time out is 13 here. The one which is greater, 13 and 12, compare these two, the greater number will be the in time for this job. So it will start the next job at 13 hours. Okay. So 13 minus 13, the idle time for C will be 0 again. Is this clear, guys? I hope you have understood this one. Let us take one more, the 7th job. Okay. As soon as job number 4 is over on machine A, it will start processing the next job, which is job number 7. The processing time required for job number 7 on machine A is 7. So 7 plus 7 gives you 14 here. Okay. Now, as soon as this job number 7 is over on machine number A, it can go for processing on B. Check the out of the previous job, which is 12. That means machine number B is sitting idle for the next job. Okay. The one which was greater, 14. So 14 comes in as the time in. So 14 minus 12 will give me 2, which is the idle time for machine number B. Okay. 14 plus 3, 3 is the processing time of job number 7 on machine B, will give me 17. But you can see machine number C is still busy because it is going to get free at 24 hours. So it is sitting idle again, or not sitting idle, sorry. But the job number 7 is over, but it cannot be processed on machine C because it is already busy. As soon as this is free, 24 will come here because 24 is greater than 17. So it will start at 24. 24 minus 24 gives you 0. That is the idle time for machine number C. Similarly, you can go ahead and start processing or doing the calculation for the other machines. I hope I have made it very much clear. If you have doubt, please refer to the previous 2 by, I can say, n jobs on 2 machine problem where I have done the calculation for each job on each machine. Any doubts here? Okay. Now going ahead, I have to calculate the idle time as well. Now calculating the idle time is very important, especially when we have n number of machines here, or 3 machines in this case. Okay. The idle time which I have calculated is only for B and C. That too, it is not complete. What will be the elapsed time, total elapsed time for completing all the jobs on machine A, B, and C? That will be the total value here. The maximum value, that is 59, minus the in time of the first job, that is 0. So the total elapsed time is 59 hours. So let us see that calculation. So 59 minus 0 gives you 59 hours. That is the total elapsed time. Secondly, the idle time for machine A is equal to the time out of the last, that is your 5th job on machine C, minus the time out of last, that is 5th job on machine A. Okay. What is that? Let me show you here. Okay. As soon as machine A finishes the last job, that is after 46 hours, it is sitting idle. Okay. On machine C, the last job gets completed at 59. So 59 minus 46 will be the idle time for machine A. Clear? So we get this calculation and we get 13 hours. What about idle time for machine B? We can make use of the calculation which we had here. So do the calculation, calculate all these values. 3 plus 2, that's 5, 5 plus 5, 10, 10 plus 4, plus 4, 18, 25. Okay. Now, once we get this value, again, when machine B completes the last job at 47 hours, okay, it is idle till the last job, that is job number 5, gets completed on machine number C. So 59 minus 47 is another idle time which should be added to the idle time of the machine B, which we are doing here. So this formula given to you here is 25 plus 12. 12 is coming from 59. That is the last job getting over on machine number C, minus 47. That gives you 12. So total hours, 37 hours. Machine B is idle. And finally, the last one, machine number C is idle for 7 hours. Any doubts? If there are no doubts, I think that's all for today. If you have any doubts, you can ask me.